Right, so it gives me great pleasure to welcome Tim today. So I've known Tim for a number of years and I would consider him a close personal friend. I hope that's okay, Tim. And on the top left of your screen, you'll see there's a photo of Tim with his wife, Meg, and another friend of ours, Bridget McCaw, who's Bill Finzer, if any of you know Bill Finzer's wife. And Tim, I can't remember the other lady's name, but we'd been to her place for dinner and we're out walking and we found this tree that was cut through the fence. But more importantly, what I want to just tell you about Tim is that some of you will know the book Get It Together. And I mean, I've been using Get It Together since I started teaching, and I'm not going to say when that was, but Tim was the key writer of Get It Together. And I went through my bookshelf and I found a few other books that Tim has written over the years. So some of you may remember back Fathom Days. United We Solved is another book like Get It Together. And then there's a couple of really cool books he's done for physics that also get into a little bit of the stats side. So that's just a little bit about, to give you a bit of a context of who Tim is. And if you can just go to the next slide. I did a bit of online stalking last night. And Tim's got a whole lot of little videos on probability that I didn't know about. So I'm just a little letting you know about that. He does a blog, so bestcasewordpress.com, and he has this little website called codeapp.xyz. So any of you that are into Codeapp, you can go and have a look, and he's got some plugins there, and he may even talk about those today, although that wasn't the purpose. And he's got a book, Awash in Data, which is an online book supporting teaching data science. So that's just a little bit of a background about Tim. I'm so thrilled Tim said he would come and present to us today, but I haven't asked him to talk about stats. I've actually asked him to, well, he will probably go there, but I've asked him to talk about mathematics because there's actually some really nice connects there that I'm sure Tim will make for us today. So, and if you can go to the next slide, it gives me great pleasure to welcome Tim to our AMA session this morning. He's going to be talking to us about connecting functions and geometry through data and modelling. Please welcome Tim Erickson, all the way from sunny, maybe, San Francisco, or actually over the bridge. But welcome, Tim, and I'll hand over to you.
Great. Well, thank you so much, Pip and Anne, and welcome everyone. Yes, I am in California, where it is 3 o'clock on Friday afternoon. So I'm still in my week, such as it is. And as Pip suggested, there's this question about what is the connection between data things and maths things. And I'm very interested in this because I adore data, and I've also worked as a maths teacher. And I think that data is part of the answer to the question, when are we ever going to have to use this in the math class? And so today I'm particularly interested in sort of secondary school, for us, grades 9 through 12, when students start to learn about mathematical functions. And in our world here in the United States, our curriculum is aimed at getting students ready for calculus, the understanding of functions. And functions are the top of this giant mountain. And you get out in the world and, I did real serious mathy, engineering-y things, and I did not use functions very much. Or rather, I did use functions, pardon me. I did not use calculus very much. I remember a day when I actually had to do an integral, and it was like, wow, that was so exciting. But I had to do data all the time. And everything that I did, and Pip mentioned the physics books, all of that work in physics was about data and using functions to model data. So let's do that. And rather than talk any more about it, let's do an activity so that we have an experience in common. And I am going to share my screen so that you can do as much of the activity as you want. I hope you actually try to do it. So I'm going to share my screen, and I'm going to look for this document here. And what you should see, and you should also be able to see little bits of me and little pictures, is this landing page. And if you want to get this landing page yourself, you can type in this URL that's up at the top, https://eeps.xyz, right? You say Z, xyz/awk22. And so you can see if you can find this page and have it look just like this. And this page has links to everything else that you will need for this session. So if you have bookmarked this URL, you can stop taking notes. Everything else will be here. So I'm going to give you a moment to go and find this page, https://eeps.xyz. Here, I'll even make it bigger. eeps.xyz/awk22. Did I make it bigger? We can never know in Zoom. Did it get larger? Someone signify by going like this or going like this? Okay.
Yes.
Great. And so it has my, yeah, good. And one of the things that you are supposed to have done in advance is to print out the first page of the 4-page session handout. And that looks like this. Okay. And so somebody who is showing your picture, like Elizabeth or Liesel, do you have this page? Have you seen it before? No, she says, but someone has, some people have, some people haven't. If you haven't, for some reason, printed it out, you will be observing. But if you have printed it out, we're going to be doing some measurements and things like that. So what we see here, and if you're looking for that URL, I'm going to show it to you again, just briefly, https eeps.xyz awk22. And this is what you get to if you click this 4-page session handout. But I already have it open, so I won't open it for you. So this is a page with 7 paragraphs on it. These paragraphs have exactly the same text and in the same font. And a thing that we're going to wonder about is, what is the relationship between the height and the width of these paragraphs? Now, in advance of doing this activity, I'm going to say, as I speak to you, math teachers,
not just to succeed academically at school, but also to succeed in life. We know some.
Okay, I will proceed.
Sorry.
It's okay. I didn't know if that was for me or if it was a question or just a lack of mute. All right, so in advance, I want to say, we're math teachers here. Don't be too smart for about the next 5 minutes, okay? We're just going to be really kind of straightforward. Students maybe who are 12 years old or something like that. And say, you see there are these 7 paragraphs, it's the same text, and we're interested in learning about the length and the width. What's the relationship between the height and the width of these paragraphs? And so I'm going to ask you, what do you notice about the height and the width of the paragraphs, about how they're related to one another? And this is even before we measure anything. And so go ahead and unmute yourself if you have something to say and tell me what you think. What do you notice?
As one gets bigger, the other gets smaller.
Oh, yes. So, for example, if you have a very tall paragraph like this, let's see. Now, I'm going to have to, Ablu001 says he or she would prefer to read the wider ones. I agree. let's see. So I'm going to get myself I'm trying to get myself a pen. So we could, here we go. I'm looking at I've circled a very tall one, and the tall one is quite thin. And if I circle a wide one, the wide one is quite short. And so as the height gets bigger, the width gets smaller, and vice versa. So bearing this in mind, imagine we were going to make a graph of height and width. What do you predict that graph would look like? And I am going to stop sharing and make a whiteboard. And I'm going to say, let's see, new whiteboard, open and collaborate. I'm going to make a whiteboard and say, what do you think the graph would look like if we plotted height against width? And an interesting question we have here is, if you plot height against width, what goes on which axis? And there are many great answers to that, but I'm going to give you one answer, which is, let's make a graph like this, and I'm going to put width on the horizontal axis, and I'm going to put height on the vertical axis like that. And can you see that whole thing? I'm looking at my collaborating whiteboard on a screen, and it doesn't quite fit, but if I make it bigger, you can see it? Good. Okay, and I put height a little illegibly on the vertical axis, partly because height is vertical. Okay, and we might say, oh, is it the dependent or the independent variable? It's a little hard to tell in this case, but height is vertical, so it turns out it's really great to have height on the vertical axis. And so the question is, what is the graph going to look like? And now I'm going to stop and be a teacher at you for just a moment, speaking teacher to teacher, and say, this is a really important moment. A thing that I love to do in activities like this is insist that the students predict. And this is very hard to do because at least our students hate committing to a prediction. And so because of time, I'm not going to force you to predict, but if you happen to be drawing something with some actual paper and actual pens, and you make this graph and you say, oh, what have I got? I've got width and I've got height. And I say, oh, so there, saves, good, someone is collaborating, excellent. And so this, you see this line that appeared? This is so great because it's an example of how much understanding do we already see in this piece of work? And one of the things we see is, oh, and now I think it's Elizabeth said, as one gets bigger, the other gets smaller. That's what we see in this graph. So this is evidence that a student is actually understanding something about the graph. Now, it may not be everything about the graph, and students will need some help at the beginning, even understanding what do you mean graph these things? So if I were to take the tall, skinny paragraph and graph it, that means height is large and width is small. And I'm going to try to change the color here, but I'm going to, for some reason, there we go. Height is large and width is small. And so it might be up here someplace. And the fat paragraph that's short has width is large and height is small, so it might be down here someplace, right? So the line connects those two, but we don't actually know what goes on in between. It might be something like this, or it might be something like this, or it might be the straight line. We're not sure, but the straight line is a reasonable prediction. And so we want to help the student make a prediction that's a good prediction, but we also want them to have a certain level of surprise. So what we should do now is measure these paragraphs. So I'm going to stop. I have to learn where to do this, I'm going to close the whiteboard, and I'm going to reshare my screen. And I'm going to, that's this screen here, and I have to click share or you can't see it. Okay, so now you can see these. What I want to do is measure these. I'm going to actually take, can I still draw? No, I have to actually start the whole drawing thing again. So I'm going to get the pen and I'm going to change the color because that yellow is kind of invisible. So I'm going to take each one of these paragraphs and I'm going to sort of measure how tall it is and how wide it is with my ruler. And at this point, it's now 18 minutes after the hour. We have a potential problem because if you have printed these out, I'm here in the United States where we don't use A4 paper. We use letter size paper, which is 8.5 inches wide and 11 inches tall. It's slightly different. So when you print it on your printers, they might come out to be slightly different sizes. So I would like someone who has it printed out to measure the height of this paragraph that I've already marked and tell us how many centimeters that is the way you've printed it out. Actually, everybody who can measure that, and we will make some comparisons and hope that they are all nearly the same. And of course, you could conceivably measure it on your screen, but your screen is going to definitely be different from other people's screens. And so I'm wanting very much for us to share data. And of course, if we were in a classroom, I would have printed them all out for you. They would all be identical. And so we would definitely be able to share data across our different people. So Ablu001 says 5 centimeters. Anybody else have, and I cannot see chats. Oh, here we go. So, okay, 4.75. Let's say those are close enough. So what I'd like you to do now is to measure the height and width of 2 or 3 paragraphs. Just measure ones that you think no one else is going to measure. Okay, which is, of course, you have no way of knowing, but we will get them somehow. And so we said this one was 5 centimeters tall, or maybe 4.7. And I'm going to, let's let you actually, should we do this with chat or with talking? Let's say this is paragraph A, B, C, D, E, F, and G. And so you can put in there, okay, C is 12.3. Okay, so I'm going to, this is great. All right, so you no longer need to see this, just know A, B, C, D going across, then E, F, G going down. I'm now going to change to a different piece of software. I'm going to go to CodeApp. And you can see all these things here, but I'm going to create a new document. I'm going to create a table. And I'm going to call this, rename it. I'm going to call it letter. Make new attributes, and this is going to be width. Oops. Width. Do height. Say A, B, C, D, E, F, G. Oops. E, F, G. Like that. And I'm going to enter these data. And so let's see, 12.3 by 2 centimeters wide is C. So I'm going to say 2 centimeters and 12, come on, 12.3. And you people may disagree and we can enter more. 15.6 by 1.7. Which one is that? Oh, F is 12 by 2.5. Great. 12 by 2.5. And good. And see, so 15.6 by 1.7. I think that might be G. 15.6 by 1.7. And we had 4.7, which is 5. That was A, was 5 by 4.7. And, oh, wait. Okay, E is 8.7, 3.2. Great. 8.7, 3.2. And you could be entering these in CODAP too, but for time's sake, we'll just stop there. And in fact, by all means, yes, let us stop, and I'm going to clear all of this. And you can see I've made a table up here where I've added things. Oh, G is 2 by 13. All right, well, so that was somewhere else. This maybe D was 1.7 by 15.6. 1.7 by 15.6. And Pip just said 2 by 13. That was G. Okay, 2 by 13. So you might have seen how I did this, and this is CODAP. This is a free public data analysis platform, and we're going to do just a couple things in CODAP. This gives you some idea of it, and there's a link to this blank CODAP document on the landing page. But I want to make a graph of this in order to see whether it looks the way our prediction was, which was like that. Remember, that was our prediction. So I'm going to make a graph. And to make a graph in CODAP, I'm going to drag the way you think about making a graph is you have to label your axes. So I'm going to put width on the horizontal axis. So I take width and I grab it, mouse down, click, drag, 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 width, 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 and drag an attribute to the horizontal axis. So those are the widths that I have. How about the height? We're going to put that on the vertical axis, and it goes like this. And we see, oh my goodness, it's not a straight line, right? And we have to think, oh, so if it's not a straight line, what is it? Now, again, we are very short of time. So I'm going to tell you that the very first time I tried this activity out with a group of high school students, 15-year-olds, very capable students, they immediately said, oh, it's an exponential function decreasing. And I was completely nonplussed because I'm from San Francisco, they're from Los Angeles. It was like traveling from Christchurch to Auckland and saying, you know, they immediately think that I know what they're studying in their classroom right then, because they were studying exponential functions. So they think someone comes from 500 miles away and they say, it must be exponential functions because everyone knows about what we're doing. It's not an exponential function. But I said, because I was a good teacher at the time, what an interesting idea. If you think it's an exponential function, what exponential function do you think it is? And being capable students, they tried to fit an exponential function to these points, and they failed and were able to describe to me why not. So this is very interesting. Like you could say, but if it's an exponential function, then it should have a value at 0. And it looks like as I get closer to the axis, this thing looks like it's going almost straight up and down. It might be an asymptote. So that we can say, well, what functions do you know that might have an asymptote as x approaches 0, or might tend towards 0 as x gets larger and larger? And one student finally said, oh, I wonder if it's one of those inverse things. Okay, what a great idea. Let's pretend it's an inverse thing. And so what I'm going to do is I'm going to go here to this little ruler, and I'm going to say, I want a plotted function. So I get this plotted function. If you study Fathom CODAP, you'll see f of something is there. So I click there and I say f is 1 over x. And I click apply, and oh, this is terrible. It doesn't fit at all. But then the question is, what do we have to do to that function if it's the right form of a function? And when do we ever talk to students about what's the right form of a function? oh, what do we have to, if it's the right form, what do we have to do to it? And they say, well, maybe it's not 1 over x, maybe it's 1 over 2x, or maybe it's 2 over x, because it has to be bigger, right? We have to multiply something by it. So I can change this and I'll say, what about say 5 over x? I apply that and I say, oh, this is better, but it's not right yet. So I'm going to invite them and you to say, what if it's k over x? And now nothing appears because CodeApp has no idea what k is. Well, we have a solution for this. I'm going to create a slider here. So here's a slider, and it says V1 is 0.5. Well, I'm going to change that V1. I'm going to change its name. I'm going to change it to K. Oh, look, now I have a function, and I can drag this and oh, I can't get it up high enough. Well, I need to change the axis bounds of this slider. So I'm going to grab the 10 and drag it to the left like this, so I get more numbers. And now I drag it up here and oh my goodness. That fits rather well, which then brings us to this very important question. Why should this situation give rise to this rectangular hyperbola, this inverse function? And if k is an important number in this function, what does k mean? And so we are now almost at 30 minutes past the hour. Somebody tell me, why does the inverse function work here? And if you're speaking, you have to unmute yourself. Oh, but there we go. Does it have some interesting idea? Says Ablu001, same number of words in each passage. Sophie Wright says area equals height times width. That's very cool. Height equals, Sophie says height equals over. Okay, so let us take some of the things that Sophie and some others are saying. Because Steve says same number of words in each passage. Could it have something to do with area? Let's start from the function itself. Let's say y equals k over x. And I'm hoping you can see that. So somebody nod if you can see it. Okay, great. Y equals k over x. And now we say, but I don't know what y and k and x are. Well, yes, you do actually. Height is y. So I'm going to rewrite it. Height is equal to k over, and x is the width. Okay. And so now we're going to do 7th grade algebra. Solve this equation for k. Okay, so I'm going to solve it. I'm going to say k equals height times width. Oh my God. Height times width, I know what that is. So k is in fact the area. In what units? And we could talk about that, but k is right now 24.7. That's in square centimeters. And is that reasonable? Is that possible that that's the correct area? And yeah, actually it is. It's a very reasonable area for those rectangles. So the important thing here is that, and I hope that you have done, and we're doing something nonlinear because it's kind of cool to see it in this context. But of course, you would start with linear things first. You would even start with things that are direct proportions, right? Especially if you were at younger grade levels. I know there are some people here from primary schools, and I want to show you some sort of primary E things, but this is mostly kind of secondary. But this is this nonlinear. But if you have a linear function, we really are very interested in understanding what the slope means and what the intercept might mean. Here, we don't have an intercept, but we do have this constant k. And because of the context, the geometrical context, the k actually means something. So I want to now go, let's see. I'm going to clear everything I've written. Everybody okay with you? I can't see you nod, so I won't ask. If you're okay with everything you see here, I'm going to clear this because when I go to the next thing, all the diagrams will make it a mess. So I want to go back to the page, and I have to find my cursor. There it is, where we were. And I'm going to try to say, I'm going to try to address some of these topics very quickly because we're at 32 minutes and you might have questions. What's modeling really? Data into math classrooms. Okay, so this I claim is a way to get some data into a math classroom, and it's through modeling. And so I'm going to go back over here and say, look at this curve. The curve does a great job of going through the points, but it does not go exactly through the points. And there are some sort of theoreticians of modeling who says some stuff that I really, really like. And one of them is modeling is about simplification. So the curve, in this case, is a simplification of reality. It does not give us the exact answer, but it shows a pattern that gives us some information and helps us understand the phenomena. And we know what happens. You have text and it's between two margins and you make the margins smaller. The text squirts out the top and it gets taller. That's a phenomenon that really works. But as you would, if we had a little bit more time, you'd say, but the right-hand edge of these paragraphs is jagged. And when we measure from the top to the bottom, do we measure to the bottom of the Y or just to the bottom of an M? You'll get different measurements depending on the rules that you come up with for doing the measurements. So the points are not going to fall exactly on the line. There's randomness or at least variability that comes from the context. But the math is still good. It helps us understand what the overall pattern is. And it's a simplification. Now, this is a particular kind of modeling of taking data and using functions. I also like it because I use this sort of we have a sequence that goes from geometry, from algebra to geometry, to more advanced algebra, to pre-calculus to calculus. And once you get through geometry, there's a tendency of students to forget how geometry works all the way until they get to calculus and need to know geometry again. In this case, this is a way of remembering how geometry works, but it's also because geometrical things can be very precise. So unlike data about people, these dots, even though they do not fall on the curve, come close to the curve because it's geometry, and we can use the geometry in order to figure out what's going on. Now, this gets to this thing here, the role of reasons. I'm very excited about the fact that when we did this, there are actual reasons for why the function is the way it is. But you can approach these activities in different directions. We just started with a measurement, and then we found a function, and then we found geometrical understanding from the function. But if you understood the geometry really well at the beginning, you could use your geometrical understanding when you did a prediction to make an even better prediction of the function and make predicted measurements that are better. You can approach these in either direction. But when you do it in this direction, you can get more precise measurements. Let's see. And I wanted to say the importance of prediction. I talked about that. How do I use these? What happens? And there's some student work in a packet. And I will say, let's see, 36. We've got a few minutes left. I will say, I love doing math projects, but math projects can be really problematic. You set up a math project for students and it can turn into a mess. You could do an activity like this in class and it can be very effective, but you can make many activities like this and assign them for homework. And so I assign these as homework like every week or every 2 weeks. And it's like a little tiny project. And so I want to show you some student work as part of what I'm going to call the packet tour. There's a 4-page session handout, then there's a many-page booklet that either you have been emailed or you will have it emailed. It's from a book that I wrote, but you don't have to buy the book. If you want to buy the book, I'd love it, but I'm giving you a bunch of pages from this book. And it's called The Model Shop, Volume 1, Functions from Geometry. The Volume 1 is an aspirational Volume 1. There is no Volume 2 at this point. And in it, you will see where I am, and you can write to me at tim@eaps.com or the other email address that I gave you. But importantly, you can see there are 42 activities here, of which this one is number 11, paragraph, same font size. So you can get an idea of what are the activities. And then I've included 4 or 5 complete activities in this packet. So and also the introduction, which is actually, I think, a really terrific piece of writing by me. And so I hope you read it. You can see if you've been around data and PPDAC cycle, it's everywhere. Okay. So here is, I'm going to show you these contexts really quickly. Stack of cups. If you have a stack of nesting cups, how does the height of the stack depend on the number of cups? This is linear. What does it mean? And this is something that a 4th grader, a 5th grader can actually do and make a graph, and they won't necessarily know how to write the linear function of the graph or understand exactly what the slope means, but you can make a graph and make predictions. How tall is a stack of cups with 20 cups in it? I have a stack of cups 1 meter tall. How many cups are there? You can answer these questions just by making the graph and reading the graph. Okay, next. Isosceles angles. Ooh, yes. Oops, stack of cups. Okay, suppose you have an isosceles triangle. And when we do these, you could imagine doing this very precisely by understanding the geometry. But what we do is we have the children sketch freehand an isosceles triangle and measure the angles. And so what's the relationship between angle A and angle B? And you can end up coming to understand things about that the 3 angles add up to 180, or if you already understand that, then you can make a better prediction about what the graph you'll get. Here's paragraph, same font size, that's what we did. Here's golden rectangles. Ooh, golden rectangles. Let's look at the context. Here is the page. How big is the square, depending on the number in the square? Okay, so what's the side of square 0, the side of square 1, the side of square 2? We're going to put the square number on the horizontal axis and the side length on the vertical axis. What function do you get? So that's an interesting one. Here's tilting chairs. You have a chair, you tilt it against a wall. What's the relationship between the base and the altitude? If you put base on the horizontal axis, altitude on the vertical axis, measure the chair as many times as you want, what function will you get? And you get this. Ooh, isn't that interesting? So in this packet, there are instructor notes with answers. Of course, you should do that, but I do want to show you some student work just very quickly. So here is, come on, can I do this? Yes, good. Tilting chairs. I predicted that as the base increases, the height will decrease, or when the height of the base will decrease. Cause a negative slope if it is plotted, height as y and base as x. My prediction graph is shown below. Height, base, curve like that. This student has done the paragraphs activity. And so she thinks that all of them are going to look like that. But she puts her points in a table and she confused. So I found 2 very functions that somewhat work. The first function I found is based on the vertex form. And these are the dots. And I don't know if I can make this bigger so you can see it, but she's got these dots fit really well, but then there are 3 more dots that don't fit so well. And so she didn't feel very good about that. I'm going to unzoom. But then she tried a Pythagorean sort of function and explains what she did. And this curvy function fits the points much better. And so she was very pleased with what she had done. I was pleased with what she had done too. But notice what happened. We went all the way from a wrong prediction, a wrong prediction, to a much better trying to fit, but failing to fit correctly, to a much better fit. This is the result of a bunch of work, partly by me and partly by the students, to feel okay about writing up these little 2-page write-ups. And oh my goodness, what you can understand about what the student understands based on what they put in something like this. And then here's one of my favorites from the book. This is small Ferris wheel. You can see if the Ferris wheel goes around once in a minute, 5, 10, 15 seconds, etc., 60 seconds to go all the way around. What's the straight line distance from down here to the circumference of the Ferris wheel as a function of time? And so that turns out to be a really interesting problem. And I will stop sharing and ask for questions because we have just a couple seconds left. So what would you, anything people want to know? Uh-oh, someone is speaking. Elizabeth, you're speaking, but I can't hear you.
No, I just thought it's been marvelous. I've really enjoyed it. Very stimulating and yeah, excellent. Excellent.
Oh,
Sorry,
good.
I don't
Well,
have any questions, but
all right.
I
All right.
love doing all of those things. Thank you.
You're welcome. I hope you can see that there might be a possibility of actually using some of these things at some level in one of your classes. You can see from the table of contents that there are, we've done some harder ones. There are some easier ones. And when you're ready for exponential functions, there are 4 of them that are about exponential functions and one that's a trick that makes you think it's exponential and it's not. Anyway, things like that. Any other questions? So I know we're supposed to finish at 45. That's what I'm aiming for. Yes, CodeApp is awesome. Yes, that's great. I agree. I think CodeApp is awesome too. I use it all the time.